Okay, so today I'm going over the multiplication and division properties of inequalities. So before we start, we need to kind of understand the different inequality symbols. So we've got the equation, which is an equality symbol because it says things are equal. And then the rest of these are inequality, which means basically not equal. There's something else. So we have the less than, and then the less than or equal to. So that line added to the bottom of the symbol means or equal. Then we've got the greater than and the greater than or equal to. And then we have not equal, which is just a slash through the equal sign. You can tell the difference between the less than and the greater than by what the point and the open side. So the point is always at the smaller side, and then the open is towards the larger side. And you always read them less left to right. So linear equations and inequalities are similar. They both have no exponents on the variable. That's what makes them linear. The equation uses an equal sign, while the rest of them, of the inequalities, don't use that. They use any of the other symbols. Linear equations, you basically just have an equal sign, and then you have two sides. For a linear inequality, you can actually combine these symbols. We usually combine them with pairs. You can have two symbols, and that creates a compound inequality. We don't normally do more than two. When you're combining them, they both have to be either a less than or a greater than. We don't normally have a less than and a greater than combined, and we don't do not equal to with those. Now, when you look at your possibility of solutions for equations, you usually have one number, no solution, or all real numbers. So basically any number that can work. For inequalities, you generally have for your solution a range of numbers. So it's more than one number, but it's less than all numbers. It's a subset. You can have no solution, or you could have all numbers. So the big difference is versus you get one number or you get multiple numbers, but just not all of them. So when we're solving these things, when you're solving a linear equation, you're simplifying each side. You use the addition property to move the variables to one side and the number on the other, and then use the multiplication property to get rid of any coefficients. It's very similar when you're solving an inequality. You're still simplifying the left and the right sides using the distributive property and adding like terms. When we're solving an inequality, we always put the variable on the left and then the number is on the right. So with an equation, it doesn't really matter, but with the inequality, it does because of the way that we read them going from left to right and how the direction matters on what the symbol means. But we still add or subtract on both sides. And then we use the multiplication property to get rid of coefficients, just like you do with an equation. But when you are doing it with an inequality, if there's a negative that you're multiplying or dividing, the inequality changes direction. So it flips. So that's an important difference between solving an equation and the linear inequality. So I'm going to go through this as if you've already seen the rules for the addition and subtraction properties of inequalities, because that comes first. I have a video on that. And we're going to go, okay, you've seen that. Let's now learn the multiplication division rules. So the rule depends on whether your value is positive or negative that you're multiplying or dividing. So that's why I've got C is less than and greater than here. And so let's say you're going to be multiplying by a number that is positive or greater than zero. So let's say you have some inequality A is less than B. And you can replace that inequality with any of the inequality symbols that we have here. If you are dividing both sides by this value of C and C is positive, then the inequality stays the same. So it's still less than. Or if you're multiplying both sides by this number C, it stays the same. It's still less than. So when you're solving something, you can divide or multiply both sides of your inequality by this value C, and it is going to be keeping your inequality the same. For the other side, if you're multiplying or dividing by a negative, so C is less than 0. Let's say we start the same inequality. We have A less than B. It's a really terrible inequality symbol. What happens is when you're dividing by a negative, it reverses, it changes direction. So now it becomes a greater than. And the same thing when you're multiplying both sides, it reverses direction. So it becomes a greater than. So you can multiply and divide both sides by a number, but you have to change the direction when it's a negative. And that's the thing that's different when you're solving an inequality from solving an equation. So the other thing that's different is when we're solving equations, we just have a single number. So you'll write x equals whatever your number is, or if you put it as a set, you just have your number inside the set. When we have inequalities, we have stuff that's called interval notation, where we write our answers. And then we also have just, you can write it as a set. So use this chart as a guide on how to write your answers here. And so you solve, you make sure your variable's on the left, and then you get some value on the right. And then depending on the symbol, just, this is how it's going to be written. Just change the value for A, because that's going to be whatever your number is. So this is just as a guide. So we will start small and then work our way up into more complicated problems here. So I've got 3C is greater than 6. So we want our variable on the left, which we already have. And then we want to have just C. We don't want 3C. So we need to divide both sides by 3. Now we are dividing by a positive. So we don't have to do anything different here. We just have the same symbol. We're going to C greater than 2, because 6 divided by 3 is 2. Now we want to practice writing this in interval notation, because that is the notation that is, used for everything basically, especially when you're going into college algebra. So I'm going to go back to the previous slide. So we have C is, let me go back, greater than 2. So we have something that looks like this, where A is 2. So we're going to write our answer like this, parenthesis 2, comma, infinity, parenthesis. So it's parenthesis 2, comma, infinity, parenthesis. And that's how you write your answer in the interval notation. Now I like to graph my answers so you can see why that is our answer. So if you have a number line, and I'm going to label negative infinity and positive infinity in my number line and put in the number 2. So our solution, we're greater than 2. So all the numbers bigger than 2 are solutions here. And it goes to infinity. So you can see if we're writing this from left to right, at the left point of our shading, we're at 2. The right point of our shading, we're at infinity. So that's where that order comes from. Now, when you're not including your endpoint, when 2 is not included because we're greater than 2, we usually use an open circle, or sometimes you'll see a parenthesis written there instead. And so that just means that that point is not included. So we would have this parenthesis at 2, and you read it left to right, then you hit infinity, and infinity is also a parenthesis because we can't actually hit infinity. It's not a number that we can actually touch. And so that's how we get 2, comma, infinity here for the interval notation. I have a video on interval notation, graphing, writing these inequalities, how you go from one to the other, and how you can, read the interval, do the graph, read the graph, do the interval, all that sort of thing. So if you want more detail there, you can watch that video. Here, we're just going to kind of use that table that I have so you know how to write your answer. So the second one that I have here is negative 4d less than or equal to 12. So I'm going to start by rewriting this. Now here, again, we have our variable on the left, which is what we want. We need to get rid of that negative 4. So we're going to divide both sides by negative 4. Now, when you're dividing by negative here, this is where you have to change the direction of the inequality. So I circle it, I draw an arrow, and then I do that first so that I don't forget to do that. So this is what I mean by do the direction. We have a less than or equal to becomes a greater than or equal to. So it's like it's a mirror image. You flip it from a less than a greater than. If you have a greater than, it becomes a less than. We only do that when we're multiplying or dividing by negatives. So this leaves me with d greater than or equal to, and then 12 divided by negative 4 is negative 3. So I have d is greater than or equal to negative 3. So to write this in our interval notation, we can go back to this chart. We have greater than or equal to in this case. So the equal to, what it does is where you did have a parenthesis at your number, it now is a bracket, because a bracket is when you're including the number, you're allowed to have that number. But we still can't include infinity because it doesn't exist. So that stays in a parenthesis. So when we write our answer in interval notation, we have a bracket, negative 3, comma, infinity. So we're always writing it from left to right, smallest number, and then the largest number. So are there any questions so far? Okay, so let's look at these next examples. So on the left, we've got negative h is less than or equal to negative 14. So I'm going to start by rewriting this. Negative h less than or equal to 14. So we're going to divide both sides by negative 1. When you have that negative in front of your variable, you need to get rid of it. And you can actually multiply by negative 1 or divide by negative 1. I usually divide. And when we divide by that negative, that inequality symbol is going to change direction. And so it's going to become a greater than or equal to. So that will give us h, oops, must have accidentally clicked black. H is greater than or equal to negative 14. And so in interval notation, this would be a bracket at negative 14, and then we're greater than, so we're going towards infinity with a parenthesis. And man, all of these are becoming greater thans. I probably should have chosen different symbols. Here we've got 6 less than negative m over 3. So if you see a variable over a number that's basically a fraction, that is the same as if we had a 6 less than negative 1/3 m. So those are equivalent. So you can just pull that m off and put a 1 there instead to see the actual fraction that you have. And so to solve this one, you're going to multiply both sides by a negative 3 because we want to multiply by the reciprocal. So I'm going to multiply by a negative 3. Actually, it's probably better not to use the dot, but to use parentheses because of the negative. You don't want it to look like you're subtracting. And then negative 3 right there. So that will cancel out the fraction. That will give us negative 18 is less than m. Now, we always read these from left to right. So we've got our m and the negative 18 on the wrong side. We want our m on the left, the negative 18 on the right. And so you can do this by flip-flopping, doing a mirror image. So this would be equivalent to m greater than, oh, and I forgot to change the symbol. So when I'm multiplying, I forgot. So first off, let's change the symbol. Because we multiplied by negative, we have to change the symbol to a greater than. Then we're flip-flopping, so that becomes back to a negative a less than 18, which in this case now we're smaller than negative 18, so we're going down to negative infinity, and then we are shading everything up through 18 or negative 18, and then you are not including 18 because of the less than. So the reason why we're allowed to just take a mirror image there to flip-flop is because if you've got negative 18 greater than m, I can add 18 to both sides. That's that addition property that we can do. That would give me 0 greater than m plus 18. Then I subtract m for both sides, and that gives me negative m greater than 18. And then you divide both sides by negative 1, flips the inequality, and becomes m less than negative 18. But going through all of those steps is a lot of steps, so really just what you want to know is that when you've got your variable on the other side and you want it on the left, you do a mirror image to put it on the correct side. It's just quicker. It's not as many steps there. Okay, here I've got 3/4 x less than or equal to negative 12. And so we already have our x on the correct side. We just need to multiply both sides by the reciprocal to get rid of the x. So we're going to multiply by 4/3. And I'm not multiplying by negative, so I don't need to flip it. I may have a negative on the other side, but that's okay. We're just not multiplying by a negative. So this will give me x is less than or equal to, and then we've got this negative 12 over 1 times 4 over 3. So I'm taking that whole number and making it a fraction so that I can do my reducing here. So I can divide 12 by 3, and that would give me a 4, and then that gives me a 1 in the denominator. So this gives us x is less than or equal to, and on top I have a negative 4 times 4, which is a negative 16, and then I just have 1 in the denominator, so I can just leave that 1 there. And so we end up with x is less than or equal to negative 16. So when we put this in interval notation, we're less than negative 16. We're going towards negative infinity. So I'm going to have a parenthesis, negative infinity, and I shade until I hit negative 16. And then it's a bracket because it's a less than or equal to, so it has that line there. So next example here, I have negative 3x plus 1 greater than 0. So we are going to start combining the addition and subtraction properties with the multiplication and division properties. So just like if you're solving an equation, you want to subtract from both sides, or add or subtract from both sides before you do your multiplication or division. So we are going to subtract 1 from both sides. And when you're subtracting with a negative, you do not need to change the direction of the symbol. It's only multiplying or dividing. So this gives us negative 3x is greater than negative 1. Then we're going to divide by negative 3. And this is where I'm going to change the direction, so it becomes a less than, so dividing by negative. And that gives us x is less than, and this becomes a positive 1/3 because the negatives cancel. So if x is less than negative 1/3, and in interval notation, that is negative infinity to 1/3. With parentheses for both. I should put that in silent. I had a power outage, so I had to set up the recording and do that separately, and apparently my phone somehow got unmuted. So these interval notations, these are going back to this chart right here. So the one we just did, it won't let me erase it because I had to restart my whole recording. So we just did x is less than, so that gives us a negative infinity, comma, whatever a number is, and we have parentheses for both. So, okay. So again, we are going to use both of our rules here. So on the left, I've got, oops, I'm still in the highlighter. 8 less than 2x minus 10. So what I find if I have my variable on the wrong side like this, I like to just move my variable to the left before I add the number, rather than doing the flip-floppy thing that I did on the previous one. I only do that flip-flopping if it's basically one step. So the 6, no, which one? Yeah, that was the one I did the flip-flop. 6 less than negative m over 3. It's basically one step, multiply both sides by negative 3. So since it's one step, then I do the flip-floppy. But if I have 2 steps, like I have here, then I won't do it, and I'll just move my x to the other side and then move my number. So that's just how my brain works. So we're going to subtract 2x from both sides. And so I get a negative 2x, and then that's a plus 8, because that's a positive 8, less than negative 10. Then I'm going to move the 8, so I'm going to subtract 8. And so that gives us a negative 2x is less than negative 18. Now, we subtracted for both of these. Subtraction does not change the inequality. It's only multiplying or dividing. And so in this next step, now we're going to divide both sides by negative 2. And so I need to change the inequality to a greater than. And I get x is greater than a positive 9. So negative 18 divided by negative 2 is a positive 9. And I'm not going to bother doing interval notation here because I ran out of room on my screen. So we'll just leave it as x greater than 9. You can go to that chart I have and double check and see what that would look like in interval notation. So next one, we have 3t is greater than or equal to 7t minus 35. So for sure, when I have variables on both sides, I always move the variable first. So I'm going to move the 7t because I need to have it on the left. So I'm going to subtract 7t from both sides. And you'll see, you know, when we were solving with equations, it didn't matter whether you move the number first or the variable. But I find when you're working with inequalities, moving the variable first makes sense, so that you can put it on the side you want and then work from there. And so that's why I also move the variable first with equations. It makes more sense when you're working with inequalities. Also, you know, with equations you can have the variable on either side, but I always tend to move it on the left, and it's because of inequalities, because you have to do it on the left for inequalities. So I just try to keep what I do consistent between equations and inequalities. So that way I'm not getting, you know, too confused. I just kind of try to do the same things. So 3 minus 7 is a negative 4, t then greater than or equal to negative 35 here. And so now we need to divide both sides by negative 4. And that changes our symbol to a less than or equal to. So that gives us a t as less than or equal to, and then this is going to be a fraction, 35 over 4. It does not reduce. 4 doesn't go into 35 evenly. 35 is 7 times 5, which are both prime numbers. It can't be divided by 4, so that's just our simple fraction. We do not make it an improper fraction, or it is improper. We don't make it a mixed number. And in interval notation, this is going to be a negative infinity, comma 35 over 4 with a bracket because it's a less than or equal to. And then it's smaller, so I have to have negative infinity there. Okay, here we have 2w minus 1 less than or equal to 5w plus 8. 2w minus 1 less than or equal to 5w plus 8. So I always move my variable, so I'm going to subtract 5w from both sides. And some people like to move their number at the same time. That means I have to add 1 because I have to move that number to the other side. So I'll add 1. So you can do both of these at the same time if you find that, you understand it enough that you don't get lost like that. So negative 2w minus 5w is a minus 3w. Then I have the 1's cancel, less than or equal to. Then 5w minus 5w is 0. 8 plus 1 is 9. So you get negative 3w less than or equal to 9. So I'm going to divide both sides by a negative 3. And we get w is greater than negative 3. So we divided by a negative. So I had to take that inequality, change the direction, and then 9 divided by negative 3 is negative 3. So when we're greater than, our number is always on the left in the interval notation. So that's going to be negative 3. And we have a bracket because it's equal to. It's got that line underneath. And then that goes to infinity with a parenthesis. This next one is a longer one. We've got 8 minus 6 times x minus 3 greater than, and then that's a negative 4x plus 12. I had to put a parenthesis around the negative 4 because when I was typing it, that greater than and then the negative, it wanted to turn it into a different symbol. And I'm like, that's not what I want. So I had to just put parentheses to force it to not do that. So here we've got something that we have to distribute before we do anything else. So I have to distribute that negative 6 through the parentheses, so I got an 8, and then that gives me a minus 6x, and then a negative 6 times a negative 3 is a positive 18. So I just need to distribute, and then the right side will stay the same. And now I need to add like terms on the left because I've got 8 plus 18. So that's going to give me 26. So I'm going to get 26 minus 6x is greater than negative 4x plus 12. So now I'm in the spot where I'm going to move my x to the left. So I'm going to add 4x to both sides. And then I also want to subtract 26 from both sides. So I just am trying to conserve space, so that's why I'm doing them all at once. Otherwise, I would do it in 2 steps. So the 26's cancel. Negative 6x plus 4 is negative 2x, greater than. The 4x's cancel. 12 minus 26. That is one that I know I will mess up in my head. Negative 14. So we have negative 2x is greater than negative 14. So now we're going to divide both sides by negative 2, which changes direction to a less than. And that gives us x is less than 7, because negative 14 divided by negative 2 is 7. Okay, so these are my last two. With some fraction stuff here to kind of show you what we do with these. So I have 1/3 w minus 1/2 is less than or equal to 5/6 w plus 1/2. So I like to eliminate fractions by multiplying by the common denominator, which in this case would be 6. So we're going to multiply everything by 6. So that's going to be 6 on both sides. And you're distributing. So what happens is, because you're just basically, when you multiply a whole number by a fraction, you multiply the tops, divide by the denominator. So 6 times 1/3 is going to be 6 times 1 divided by 3. And so that gives us 2w. Then when I multiply 6 times 1/2, that's going to be 6 times 1 divided by 2. So that's going to give me a minus 3 there. Less than or equal to. Now we're going to do the other side, and we're going to take that 6, multiply by 5 over 6. So that's going to be 6 times 5 divided by 6. So that's 30 divided by 6, so that gives us 5, so that's 5W. And then 6 times 1/2, 6 times 1 is 6, divided by 2 is 3. So that's the trick that I do with whole numbers and fractions. Multiply the top, divide by the bottom. So we end up with 2W minus 3 is less than or equal to 5W plus 3. So we're now going to start moving things. So I'm going to subtract 5W from both sides and add 3 to both sides. So 2W minus 5W is negative 3W. I have a less than or equal to, and then 3 plus 3 is 6. So now you want to divide both sides by negative 3. And we're divided by negative, so our inequality changes direction. Now that's going to become a greater than or equal to. And that is W, and then minus 2. One of the most common errors is people forgetting to change the direction. And even sometimes I say it out loud, I don't change direction, and then I have to go back and be like, wait, I need to change direction. So you just have to, when you're doing these problems, be slow and be careful to make sure that you don't forget that step. Now the last one I have is 5t plus 7 over 2 is less than t minus 4. So we want to get rid of the fraction 2, and we do that by multiplying both sides by 2. So that will just cancel out that fraction on the left, giving me 5t plus 7. And on the right, you need to distribute. So I get 2t, and then 2 times 4 is 8, so that's a minus 8. So now I need to get the t, so I'm going to subtract 2t from both sides. And I'm going to subtract 7 from both sides, so I can just make sure everything's all on the right side that I need it to be on. So 5t minus 2t is 3t, less than, and then negative 8 minus 7 is a negative 15. And so now I'm going to divide both sides by 3, and I do not need to change the direction because I'm dividing by a positive number. So that stays as it is, and its t is less than negative 5. So these are basically, a good set of problems that you might see when you're solving linear inequalities. The key is to it's the same thing as solving an equation, just make sure your variable's on the left, and that when you're dividing by a negative or multiplying by a negative, the inequality flips, does mirror image. But other than that, the steps are pretty much the same. You do write your answer slightly differently, but that is what my lovely chart is for, so that you can just kind of put this on a note card or whatever you need it, so that way you can refer back to it. So hopefully this was helpful, and I will talk to you guys later. Bye.